we will see how to evaluate integral e raised to minus at ft dt from 0 to infinity by Laplace transform. By Laplace transform, we know that phi of s equals integral from 0 to infinity of e raised to minus st ft dt. We find we have to replace this s by this a, so we will get integral from 0 to infinity e raised to minus at ft dt to be phi of a. For example, integral from 0 to infinity e raised to minus st sin t dt is 1 upon s square plus 1 square. Therefore, integral from 0 to infinity of e raised to minus 2t sin t dt will be 1 upon, replacing this s by this 2, it will be 2 square plus 1 square 1 upon 5, or integral from 0 to infinity e raised to minus st cos 5t dt is s upon s square plus 5 square. Therefore, integral from 0 to infinity of e raised to minus 3t cos 2t dt will be, by replacing this s by this t, will be 3 upon 3 square plus this 2 square, which will be 3 upon 13. Hello friends, you are watching YouTube channel Number Collage. This channel features videos on mathematical concepts. Effort has been made to explore the concepts through basic mathematical ideas. Hope you will like my effort. You can even check playlist of this channel. Perhaps you might find videos that you are looking for. Evaluate integral from 0 to infinity e raised to minus 2t into sin cube t dt. We have sin 3t equals 3 sin t minus 4 sin cube t. Therefore, this sin cube t will be 1 upon 4 times 3 sin t minus sin 3t. So we replace this sin cube t by this expression, which is 1 upon 4 times this 3 integral from 0 to infinity e raised to minus 2t into sin t dt minus integral from 0 to infinity e raised to minus 2t into sin 3t dt, which is 1 upon 4 into 3 into 1 upon 2 square plus 1 square minus 3 upon this 2 square plus this 3 square, which is 1 upon 4 into 3 upon 5 minus 3 upon 13. 3 upon 4 into 1 upon 5 minus 1 upon 13, which works out to be 6 upon 65. Integral from 0 to infinity e raised to minus 2t into sin of t plus alpha into cos of t minus alpha dt equals 3 upon 8. We have to find alpha. By defactorization formula, we have sin a cos b equals half times sin a plus b plus sin a minus b. Accordingly, this integral will be integral from 0 to infinity e raised to minus 2t into half times sin t plus alpha plus t minus alpha plus sin t plus alpha minus t plus alpha dt equals 3 upon 8. This will be half times Laplace transform of sin 2t after cancelling alpha plus Laplace transform of sin 2 alpha after cancelling t, which is 3 upon 8. 2 1s are, 2 4s are. Laplace transform of sin 2t is 2 upon s square plus 2 square plus Laplace transform of sin 2 alpha is sin 2 alpha into Laplace transform of 1 upon s. This is because sin 2 alpha is a constant, which equals 3 upon 4. Now we replace this s by this 2. So we get 2 upon 2 square plus 4 plus sin 2 alpha upon 2 equals 3 upon 4, which will be 2 upon 8 plus sin 2 alpha upon 2 equals 3 upon 4 sine 2 alpha upon 2 is 3 upon 4 minus 2 upon 8. 6 minus 2, 4 upon 8, 1 half. Cancelling 2, sine 2 alpha is 1, which implies 2 alpha is pi by 2. Alpha equals pi by 4, which is the value of alpha, pi by 4. Evaluate integral from 0 to infinity e raised to minus 3t into t raised to 5 dt, which is nothing but Laplace transform of t raised to 5, and we have Laplace transform of t raised to n equals n factorial upon s raised to n plus 1 if n is a positive integer. Therefore, this integral I becomes 5 factorial upon s, which is 3 here, raised to 5 plus 1, 120 upon 3 into 3 raised to 5, 3 ones are, 3 fours are, so this integral is 40 upon 343. Viewers, if you like this video, please click the like button. Share this video with your friends and classmates. Subscribe to this channel. Post your constructive comments to make the videos better. You can even check playlist of this channel. Perhaps you might find videos that you are looking for. See you in the next video. Until then, keep watching Number Collage. Thank you.